Hey guys, this is Dan, and today we're going to be looking at financial mathematics in Excel. So, we're going to be using as an example to learn financial math in Excel, the oldest get-rich-slow trick in the book, which is going to be buying out a house on a mortgage and then renting out that very same house. All right, we're going to be looking at a ton of equations, formulas, and other stuff in Excel, and it's going to be pretty exciting. So make sure you cancel your Saturday night plans, your date, whatever. This is going to be way much more fun. Yes, Excel is always much more fun than going out. All right, guys. So let's get started. Let me tell you about the situation that we're going to be analyzing using Excel's built-in financial mathematics formulas. Now, it's pretty run-of-the-mill. We have here a big apartment that's in one of the poshest areas of the city. Now, the city I'm talking about is Guadalajara. For those of you that are watching me from America, that's right next door to Puerto Vallarta. For those of you that are watching me from the rest of the world, you're never going to figure out where that city is. It's pretty irrelevant, all right? But whatever. I mean, it's one of the poshest areas of the city. You're right next to a country club, and you're right next to Colomos Forest. I mean, it's pretty nice. And this really nice apartment, is for sale at just 260 grand, all right? 260 grand. Now, I know that for you Americans, that's peanuts because, I don't know, property markets in American cities are way out of line. They're like, an apartment like this would be like $4 million in Seattle or something. All right. So the apartment is also 2,300 square feet. All right. It's also 2,300 square feet. So that's a pretty decent size. And the neighborhood is Providencia. So we're going to be taking out a loan to buy this apartment. All right. We're going to be taking out a loan to buy this apartment. And this is the data that the bank has applied us with. All right. We need to pay a down payment to a bank. It's going to be for 10%, so that's $2,600. I'm sorry, 26 grand. The bank also has to send a person to do evaluation of the apartment, which pretty much means that they're going to send a guy to take a look at the apartment, and that person is going to say, oh yes, it is worth $260,000. All right, and they're going to charge us $750 for that. But the real robbery that's happening here, the real highway robbery, is the legal fees, all right? We are going to have to pay $18,000 in order for the government to say, yes, this is no longer the seller's house, this is now the buyer's house. And that's pretty much it. So, I mean, if you want to know why lawyers are so despised in every single country in the world, this is pretty much it. They're charging you $18,000 to shuffle some paperwork around. All right. So the initial outlay, the money, the cash that we have to have on hand in order to get this mortgage approved is 44 grand. Well, almost 45 grand. And that's a pretty hefty chunk of change, but there's nothing you can do about it. After you've paid out that money, then the bank is going to happily loan you $234,000 so you can become the proud new owner of a luxury apartment in one of the nicest areas in town. All right, guys, in one of the nicest areas in town. Now, this is going to be, the rates in Mexico right now are about 11%. TAC means total annual cost. That includes taxes, that includes insurances, that includes every single thing that the bank tax onto your loan. So this is the one that we use. Now, we're supposed to be taking out the loan at 15 years for a 15-year loan, and we're going to assume a 5% inflation. Remember, that's how fast your money loses value. I mean, it's 5% right now in Mexico. I'm not sure in America how much is it, but I think it was like under 2%. All right, and we're going to be using all of this data to calculate how the payments are going to go. And you're going to be learning a lot about mortgages and well, loans in general. All right. Now, after that, in the next video, we're going to simulate that we're going to rent out the property. All right, we're going to rent out the property, and we're going to see if this is actually a viable scheme for getting rich slowly, because it's not a get-rich-quick scheme. All right, so that's going to be for the next video. Right now, we're going to check out how much we're going to be paying out in total to a bank, and in here, we're going to be checking out how much money we're going to be receiving in total from rents and appreciation and stuff like that. All right, and we're going to see if it balances out, if we can actually make some profit. All right, guys, so let's get started. Where the money comes from. I'm going to reduce the finance profession to basically just two items, which is pretty much what finance people do all day long, wherever they're working. They're trying to figure out the cheapest way to get money. They're either raising it from investors or asking for loans or telling your grandma to shell out her retirement money, whatever. And once they get the cheapest source of money available, they're trying to spend it on, or they're trying to invest it in the highest returning asset possible. That means they're going to find whatever generates the most amount of money. If you can do this successfully, then you have triumphed as a financial analyst or as a finance person in general. All right. Now, easier said than done. Let's get started with this one. We have this apartment with it's worth $260,000, but the amount that we're going to be looking at is how much we're going to be getting from the bank. Remember, it's $234,000. So, in order to get this analyzed in Excel, we have to make some changes. Now, if you took financial math in college, or God forbid you even did it in high school, you would have taken a ton of, you would have used your old HP calculator, because schools have yet to learn, business schools have yet to learn that Excel exists, all right? But Excel will do a ton of stuff. Excel will do pretty much every calculation for you, so long as you respect this one thing. Excel wants everything monthly, all right? Since we're going to be doing our amortization table, let me just change that up, amortization table. Since we're going to be doing our amortization table right here, and it's going to be evaluated on a month-by-month basis, then we need to figure out how much we're going to be paying out every month for the loan, and Excel asks us for the rate to be converted into a monthly rate for that very same reason, all right? We want the monthly outlays that you're going to be paying to a bank every month, then Excel demands of us that we give it the rate in a monthly fashion. All right, so monthly rate, it's going to be 11.30%, which is this one, divided by 12. Now, I know some of you mathematical nitpickers are going to be ready to hang me right now, because that's not exactly how it's done. But for the rest of you that are either finance neophytes or are not so nitpicky, dividing the annual rate by 12 is pretty close. It's a pretty close approximation to the correct procedure. The correct procedure actually involves exponents and complicated stuff like that. So just divide the rate by 12, and it's going to get you pretty damn close to what you want to calculate, all right, to what you want to get. Now, number of periods. Number of periods should be 15 years, but it's not that, because we need to translate it to months. So it's actually going to be the 15 years multiplied by 12, and we get a loan of 180 months, all right? And then we get to brass tacks, which is the monthly payment. The monthly payment is how much we're going to be paying back to a bank each and every single month for all 180 of those months that we have the loan outstanding, all right? Now, either you can calculate it using financial formulas, and those are pretty complicated, or you can use Excel's built-in PMT formula, all right? PMT is short for payment. And what this is going to do is it's going to ask you a bunch of stuff, and once you give it what it wants, you're going to get back the payment amount, all right? So the rate, that is the monthly rate, all right? That is the rate per period. If you are expecting monthly payments, then Excel is asking you for the monthly rate. If Excel is expecting quarterly payments, then it's asking you for the quarterly rate. And if you're expecting annual payments, then Excel is asking you for the annual rate. I don't know how much more clear than that I can go. All right, guys. So I select over here the monthly rate, number of periods, that's going to be 180 periods. And finally, present value, guys. Present value, that's going to be how much money the bank loaned us, which is going to be 234 grand. All right, guys. So I'm going to press OK, and right here we get how much we're supposed to be paying out back to a bank. Now, first things first, we notice that it's $2,700, but it comes with a negative sign, all right? It's a minus sign. What does that mean? All right, it doesn't mean that the bank loans you money for you to buy a house and then gives you $2,700 every month. No, it doesn't mean that. What it means is, when you're talking about financial mathematics, when you have a plus sign in front of something, that means that it's cash that's coming into your pocket. So the bank gave you $234,000. That means that you're going to be receiving that money getting it into your pocket. I mean, you're going to be using it to buy the house anyway. But then every month you get to pay back the bank $2,700, and that's why the minus sign. It's cash that's leaving your pocket. Now, this is all prim and proper for financial mathematics, and it's the way that it's supposed to be. But for practical purposes, like say, for example, doing the amortization table, it's totally unnecessary because you actually need the money to be positive. I mean, you need it to be in a positive sign. So let's just leave it at that for now, but keep in mind that I'm going to be reversing the sign once I get to amortization table. All right, last but definitely not least, it's the monthly inflation. All right, I don't need to calculate that right now for any financial formula in Excel, but it's pretty useful to have it. All right, so inflation is supposed to be 5%. I divide that by 12, and now I get that the Mexican peso is going to be depreciating 42% in purchasing power, 0.42% every month, all right, in purchasing power. All right, guys. So that's it. Let's get started with our amortization table. Notice that I already gave you the template here. You already have the template, and you have the titles here for all of the items. Now, the month is going to be from 1 to 180, and we're going to be checking out how much we're going to be paying every month. So for month 1, at the start of month 1, the amount outstanding is going to be, well, the loan amount. That's what the bank gave us. Oh, I failed. I'm sorry, guys. You shouldn't be looking at videos from me. Here we go. All right. The amount that's outstanding is those $234,000. Now, the total payment, that's going to be how much I'm paying back the bank every month. And if you remember, we already calculated that using our trusty PMT formula from Excel. Now, the problem here is that this isn't the sign that I want to use because it's just going to confuse people. So I'm going to change the sign by grabbing my Excel reference and multiplying this times minus 1. All right? So notice how the formula is cell P19 times minus 1. All right, guys? Now, interest payment. Well, that's pretty nifty. This is where we get to the interesting parts. Interest is usually calculated in most loans as the amount outstanding times, well, in this case, the monthly rate. All right? In this case, the monthly rate. And finally, capital payment is the total payment minus the interest payment. The amount due then is the amount outstanding minus the capital payment. Now, you'll notice I breezed through this pretty quickly because I'm going to explain to you right now, all right? And Americans don't have this problem that much with houses, but when it comes to college loans, I don't know, the amount of people taking out college loans and not understanding what I'm about to explain to you is pretty damn high. I mean, worryingly high. But what I'm talking about here is, say, for example, we had $234,000 from the outstanding amount. Now, our Excel formula, PMT, is telling us that we have to pay back $2,700 every month for the next 180 months in order to settle my loan, all right? But most loans are structured in the following way. They are front-loaded with capital, with interest, I'm sorry. That means that you're going to pay up most of the interest up front during the first 3-4 years of your loan. That means that you're going to be paying painfully every month $2,700 each and every month, and you're not going to be getting a lot of, you're not going to be paying a lot to the bank to settle your loan. You're actually going to be paying a lot to a bank in interest. That is pure profit for the bank, and capital payment is what's actually going to get subtracted from the amount outstanding, all right? So that's why the amount due in the end is going to be the amount outstanding minus what I paid in capital, all right? So a lot of people usually, and especially this happens with college loans, a lot of people usually ask for a loan, for a college loan, and then they pay the minimum payment without realizing that they are actually contributing very little towards paying down the capital that they were loaned in the first place. They're just paying interest. So you can be paying for like 5-6 years and realize you've only made a $2,000 dent in your loan. And it's pretty sad, but most people don't understand the mathematical structure of loans, which is this, all right? Interests are loaded up front. Capital is the thing that you pay at the very end of the, capital is mostly paid at the end of the loan, all right? At the end of the loan term. So let's check that out. Now, the first step towards doing the amortization table is pretty much copying what I did. But the second step requires, the second line requires me to do a different set of steps, all right? It's pretty simple. The amount outstanding is no longer the original $234,000. It's the amount due at the end of the first month, all right? So it's this 233 grand. All right, so now that's what I owe. The total payment, as always, is going to be this one multiplied times -1, all right? And since it's always going to be referencing P19, I need to do an absolute reference there. So I'm going to press F4 here. You notice how I get my dollar signs, and that's an absolute reference. Now, this video is not the place to learn absolute and relative references in Excel. I have another video for that, all right? Right now, I'll just assume you already know that. All right, so as usual, the interest payment is going to be the result of the amount outstanding times the monthly rate. And since the monthly rate is always going to be placed here in P16, I also have to apply F4 to that. All right, guys. So interest payment, notice how it went a little bit down. Now it's $5 less. And that means our capital payment is going to be $5 more. For capital payment, remember, I grab my total payment, subtract whatever part the interest was. Notice how it's $5 additional in capital payment, and the amount due is now going to be amount outstanding minus capital payment, all right? So I've made, in 2 months, I've made $1,000 dent in my loan, even though I've already outlaid $5,400. The rest goes to interest for the bank. All right, if we have our formulas correct, now we can grab this second line and drag it all the way down. All right, guys, drag it all the way down. How do we know we're right? Well, the amount due at the very last month should be, at the end of the very last month, should be $0. All right, exactly $0. Now, notice the structure of capital that I'm talking to you about. The loan structure that I'm talking to you about right here. Interest payment starts out high. The first month you're paying $2,200 in interest. Whereas, say in month 130, you're already only paying every month $1,000 in interest. And at the very last month of the loan, you're actually just paying $25 in interest, all right? Now, capital goes the other way around. You start paying $500 in capital, then you go up to $1,000 by month 75, and by the very end of the loan, you're already paying, most of your monthly payments are pretty much capital, all right? Just $25 in interest, and most of your monthly payments are capital. So banks structure this in such a way that the risk is minimized for them. Why? Because you take out your loan when you're pretty happy and confident. You have your husband just got a great job, your kids are not sick, you're making tons of side money on your Etsy shop or whatever. You take it alone when you're happy and confident. And let's say you can get that happy lifestyle going for like 36 months. All right. So on month 36, you've paid the bank $76,000 in interest, but you've only made a $21,000 dent in your debt. All right. So say after month 36, the kids get sick, husband gets fired, your Etsy shop falls down, you're screwed, you're out of money, you're not making any money anymore. So the bank is going to come back, repossess your house and say, oh, I'm going to sell it and give you back the money you paid, which is only 22 grand. But as far as the interest goes, that's mine, says the bank, all right? And I get to keep that 76 grand. So the bank now has a house and 76 grand. They're going to lose some money on foreclosing the house, but still, this minimizes risk a lot for the bank, front loading the interest. Remember that out of the total interest that you're going to be paying, $252,000, most of it is going to be paid before the loan hits half, all right? Say half of the loan is right here. 172 grand is already going to pay before half of the loan gets expired, all right? Whereas the stuff that you're paying towards yourself, that's capital, the bank is going to let you pay it at the very end. Now, I know this sounds evil. I know this sounds like we need more financial regulation. No, I'm sorry. That's just the mathematical structure of the loan, all right? That's how financial mathematics works. Most loans are structured in this way to make sure that interest is front-loaded, capital is backloaded. And this is something that you need to understand when you're taking out a loan. Most of the contributions you will make towards paying down your loan is going to be toward the end of life of the loan, all right? The end of life of the loan. Now, let's get over here to loan results. Loan results, by that I mean, I usually like to break out for my students in the classroom how much they're going to be paying in interest, in capital, and the total payments. And that's usually where they get shocked because, well, it's pretty much a lot, all right? Now, the sum of total payments is just going to be the sum of everything right here in the total payment column, all right? So the bank loaned you $234,000, but you're paying back the bank $486,000, all right? And the sum of interest paid is going to be the sum of everything right here in the interest column, all right? Whereas the total capital paid is going to be the sum of everything right here in the capital column. All right, guys. So check this out. Bank loaned us $234,000. We paid it back $234,000 in capital. But total interest paid is larger than capital. We paid more interest back to the bank than capital. I mean, more than they loaned us. In just 15 years at an 11.30% rate. Now, I know that Americans have much lower rates. I'm not sure, but I think you can ask for around 5 or 6%, at least as of this recording in 2018. But not all is lost, right? Not all is lost. Why is it still viable for a mortgage to result? I mean, most people would see this and they just give up. They just say, oh my God, I'd be better off renting. Well, probably not. Let's check some stuff out. Remember this little friend that we have here, inflation? All right, let me point it out for you. All right, inflation is pretty important. Inflation means that the value of your money is your money is actually going to be losing value month after month because stuff is going to get more expensive. And while inflation is generally bad for savers, for you guys that are asking out for loans, that inflation is a godsend because it reduces the financial impact of your monthly payments. What do I mean by that? Say you're paying $2,700 today in month 1, all right? Now, you pretty much, right now, if you're looking at this video in July 2018 when it's being recorded, you have an idea what $2,700 gets you, all right? You know how many gallons of gas you can buy with that? How many avocado toasts you can buy with that if you're into a hipster stuff? You know, I don't know, what else? How many gigabytes of data you can buy with that? Whatever, all right? But we fast forward into the future, 180 months into the future, and you know prices for everything are going to go up. So paying $2,700 in month 180, 15 years into the future, is not going to be as painful because prices are going to have gone up and $2,700 is not going to be worth as much as it was today, all right? You're probably, I mean, I don't know, Americans have their prices doubled like about every 30 years, I think. But in Mexico, 15 years, that's pretty much enough to double the prices, all right? So that means $2,700 is going to be half as painful in 180 months as it was in month 1. And we have to take that into account. So how would I go about calculating the present value of the loan, which would involve subtracting the effect of inflation from it? Now, this seems like a pretty complicated calculation because that implies that inflation was just, I don't know, monthly inflation was 0.42% in month 1, and God knows how much it had compounded to, all the way to month 180. There's several ways to go about that. I'm going to calculate it by hand, but you should not do this, all right? It's pretty complicated. I'm going to do inflation here. Oh my God. Okay, inflation, and check out how it would be calculated by hand. Don't worry if you don't get it. This is pretty advanced math. Only 9th graders can actually get to this, all right? Or maybe even 10th graders. Say, for example, we're going to be grabbing our total payment. Then we're going to be dividing it by 1 plus the inflation amount. And that is going to be raised to the nth power. The nth power being the month. All right. The inflation amount, I need to do an absolute reference in that. All right. That is how much we're actually paying. I mean, we're paying $2,700, but it's going to feel like $2,692 because inflation is going to make prices go up. Now, you notice this is a pretty insignificant change, $10. Okay, who cares? But once I drag it all the way down to month 180, We're still going to be paying $2,700, but it would feel as if we were paying $1,200 today, all right? Because since prices went up and salaries are supposed to go up as well and stuff like that, it's not going to be as painful, all right? It's not going to be as painful. And that is how I calculated inflation. Notice how I said that it's a task that only 10th graders can do, because only 10th graders use exponents, all right? After that, you forget about them. And before that, you don't know how to use them. But only 10th graders actually use exponents throughout their daily lives in Algebra 1 or whatever. All right, guys, so you don't need to get this, all right? When you actually were using exponents in high school and you raised your hand and asked your teacher, what is this going to be good for? And your teacher said, oh, you don't understand, you uncomprehending young person. It's not going to be good for anything because I present to you Excel. Excel can actually calculate this for us. How would it go about doing that? Well, we have this formula called present value. And as you'll guess, it's called PV in Excel, all right? PV. Now, I'll go over here to FX. And we'll get a rate here. We'll get a rate here. It's asking us for a rate. Now, this is not about mortgage. This is about inflation. So it's not the monthly mortgage rate. It is the monthly inflation rate, all right? It is the monthly inflation rate. Number of periods. We're going to be discounting inflation throughout the whole life of the loan, 180 periods. And the payment amount. Well, the payment amount that we want to be discounting is this one, all right? It's this amount. It's this amount. All right, guys. So I'm going to leave it at minus 2,700 because remember, pluses and minuses when it comes to cash outlays, they are pretty important. It's pretty important that we respect them when we're using our financial formulas, all right? It's just not important to respect them when we are doing the amortization table by hand. All right, so I'm going to ignore FV and type, all right? I'm going to ignore FV and type. FV just means future value. The future value of the loan should be 0 because it should all be paid for, all right? Notice how that doesn't change anything. And type is whether we pay the loan at the start or at the end of the period. Now, that's a little bit more complicated. It's for people that are like, I don't know, Finance 2. Guys, so right now that you're in Finance 101, let's not take a look at that. All right, let's do okay. And this is the present value of our loan, actually. So that means that if we were to take all the cash outlays throughout time, I mean both for interest and for capital, or pretty much the total payments throughout time, and discount the effect of inflation on them, that means that if we want to pay all of the loan upfront, including the interest, I don't know why you would want to do that, but it's just a theoretical exercise, it would be worth $341,000, all right? In other words, the effect that inflation is going to have on how it feels for you to pay your monthly payments, it's not going to be as if you're paying $486,000. It's going to be actually more like $341,000. Because remember, the payments are going to get less and less and less painful every month, because even if you're an incompetent nincompoop good for nothing that never gets a promotion, salaries should go up. Salary should go up just because of the inflation, all right? And since prices are going up, then it doesn't feel as bad. It doesn't feel as bad that you pay $2,700 well into the future, all right? Not as bad as paying them today. All right, guys, so that is the present value of the loan, and that is exactly how much we're going to be paying. Now, for those of you guys that are actually more advanced in finance, you'll know that banks grab loans and they package them and then sell them off to, pension funds and investment funds and mutual funds and all sorts of funds, all right? And you'll know that was pretty much the cause of the 2008 financial crisis in a nutshell. I mean, they grabbed all of these garbage loans and then sold them off as AAA rated pure gold loans of these pension funds. But that's not the point that I'm trying to make. The point that I'm trying to make is that if the bank did not want to wait around for you to pay all of that and they needed the money right now, they could package the loan, sell it at $341,000 to some pension fund who is okay with waiting 180 months for all the money to roll in, all right? So that's another way to understand the present value of the loan, all right, guys? And that's pretty much it for mortgage calculations in Excel. We learned how to do our amortization table, and we learned how to use the PMT formula and the present value formula. Now, I have other calculations here because there's some other stuff that we want to calculate, and it's not really necessary unless you're really, really into finance, but let's check those out, okay? the first thing that we're going to be calculating is, say, for example, what if I wanted to know how much interest I paid during the fourth month without doing the amortization table, all right, guys, without doing the amortization. Well, for that, you have a formula called IPMT, all right, which would be the abbreviation for interest payment, all right, guys? So let's check out what this formula does. It's asking us for the rate. Remember, we need the monthly rate. The periods. Well, we want the interest payment for the fourth period, all right? We want the interest payment for the fourth period. Number of total periods. Well, that's 180 periods right here. And the present value is how much money they loaned us in the first place, all right, guys? There we go. So it's telling us that we should be paying out $2,100 in interest. Let's make sure that's true. How would I go about proving that? Well, I just look at my interest payment in month number 4. 2,189 with 23 cents, 2,189 with 23 cents, all right? So this table right here is vanity. Excel can calculate our interest payments pretty simply just using this IPMT formula, all right? Just using the IPMT formula. Now, right here I have the monthly rate, number of periods, and what I wanted to calculate was the monthly payment. But this is just like a mathematical equation. I can also use, say for example, if I don't have the monthly rate, if I were to get rid of the monthly rate, I could use the number of periods and the monthly payment and the present value to get the monthly rate. And I don't even need to do any equation solver or anything. Excel already has the formulas for that for me. So the monthly rate is going to be, well, pretty simple, all right? It's going to be called rate, all right? The rate formula is asking me for the number of periods, the payment amount, and the present value. And notice that I get the exact same amount that I had as the monthly rate. And this also applies for number of periods. I just use the unpaid formula, which is number of periods, and you'll notice it's going to be asking me for everything else that I already have except unpaid. So we have the rate, we have the payment, we have the present value, and that gets us to 180, all right? 180 periods, all right? And finally, we're going to use the future value formula, all right? We're going to be using the future value formula, which is going to be called FV, all right? FV will actually give us the future value of a set of payments. Now, in this particular case, since we are paying down a mortgage, we expect the future value of this set of payments to be 0, all right? So the monthly rate is going to be this one, 180 periods, this payment's in negative, and the present value is how much they loaned us. Notice how it's optional, but we need to include that to get an answer that makes sense. So this is pretty damn close to 0. Notice how I get exponent minus 9, whatever, it's 0.0000116, all right? Why doesn't it do exactly 0? Remember that my monthly rate, I divided it by 12 instead of doing the mathematically correct stuff. So I'm off by, I don't know, 0.00001 cent. So that's why there was no real reason to nitpick. It's pretty much 0, all right? So the future value at finish of the payment is just as we predicted right here in our table. It's going to be $0, all right? $0 due, or $0 here. All right, guys. And now for real, we are done here. I hope you enjoyed the video, and please make sure that you click like, that you subscribe, that you comment, and if you are angry at the video for any reason, well, you don't have to do any of that. Now, in the next video in the series, we're actually going to be looking at the formulas that are necessary to calculate how much an investment is good for. All right, we're pretty much going to be grabbing this very same apartment and renting it out, and calculating if we can actually beat the bank or not by renting out the apartment.